Hey guys, I just want to show you how I designed the propellers for my EDF. I'm using SolidWorks 2019. So here is the overview of my propeller right now. I'm using for my EDF right there, but the one I'm gonna show it's a bit different, almost the same, but just small difference. Okay, so you start usually from the defining what's the pitch angle, how fast is your propeller going to spin, and how fast the air outtake you need to get. And based on that, you're gonna get your efficiency and all the pitch numbers. The pitch usually is defined in the inches per rotation. So you can imagine like a spiral, like this, for example. This is spiral, you see, but this is just a 0.25 revolution. But for example, if I go 1 revolution, so see, I have the pitch equal to 300 millimeter. That means that for 1 rotation propeller, the air will travel 300 millimeters, which equal to some kind of degree. You just can calculate that angle. One time I was using the inches, the other time, like right now, I was just using the angles, like this, for example. EDF have very weird, EDF propellers have very weird design, because the problem is that they optimized for you see these in the root, the angle is so crazy. This area optimized for very high airspeed. This one optimized for low speed. So the propeller, the surface of the blade doesn't work efficiently, unfortunately, all the time. If you want to use efficient 100% efficiency for your blades while spinning, you need to make adjustable pitch angle, like in some airplanes. It's very complicated to do it in EDFs because of problem is the RPM is crazy, and if you have a disbalance, just a 1 gram or 2 gram, depends on your construction, it can just destroy all your bearings and everything. It just will be a big mess. So usually they make it static like this, especially if they want to make cheap. So that's why the shape of the propellers is like that. You have the pitch here is 30 degrees, pitch here in the root is 69 degrees. In inches it will be, I cannot tell you, like 7 inches here, and let's say 12 inches here, almost 2 times. I'm just saying you numbers from nothing. You can check the internet. So to calculate the pitch in inches or meters, centimeters, you have to know the radius from center to the place where is your airfoil, and you need to know the angle of that airfoil, and then you can calculate the how much distance the propeller will travel through the air for 1 rotation. Okay, so in order to make nice and beautiful blade, you need at least 2, maybe 3 airfoil cuts, cross sections. I have 1, 2, 3, 5. One in here, which is just duplicating the root one. It's for design purpose. Unfortunately, I had to make it because otherwise it gives me a little bit wrong curvature. Okay, and this is how airfoil looks like. So this is just a static. I draw it, use the sketch tools, but you can also insert the formula, and you can find those formulas in internet for each airfoil. There's like AR15. I don't remember the right numbers, like AR something. Each airfoil has unique number, unique text. So you can find a formula, mathematics formula, you can paste it here, it will draw it for you, so it works. But unfortunately it didn't work for some of the airfoil forms for me. I don't know why. It's because of the .NET framework, something error. So I decided just to do it manually. Yeah, that's it about airfoils. So you put airfoil for different radiuses and just use a loft tool like this one, and you connect them all together like this. And here you got your blade. And as you can see, I have very like drawn kind of curvature. It's quite an experiment because I've seen it in the internet. Then some propellers in EDF has that weird shape on the very end, maybe to pick up more air or something. I don't know. I just tried to do the same. That's why I have this drunk, or I don't know, very not straight line form. Okay, so once you made your one blade, you just duplicate it. That's it. All you need to do, and the rest is up to you. Looks beautiful, right? Okay, let me show you the propellers I made. So this is the original propeller. It's a very nice quality plastic. I think it's, I don't even know, carbon fiber, whatever, I don't know, but it's very strong. Like, if you take a caliper and measure thickness in here, sorry, it's whatever, 2 millimeters, and in the root is like 2.5, and it's very strong, really. I barely can bend it a bit. It's very good material. So this is the original propeller, which was coming together with this Freewing EDF, which I love. It's a very good one. The efficiency is very good. Unfortunately, I don't have like a fancy one, like HB Hobby or whatever the name. They're very expensive. I have just this one for $100 from AliExpress. So my idea was, can I make the propeller by myself? I know it's not safe. I know. So please, you can leave your comments how stupid it is to make something like that. I need to use a protection glass, whatever, to protect myself. Okay, so skip that part. This is original propeller. This one is a V1, I call it. This is actually V1 for SLA. It's a resin printer. So I was using PLA as well. But let's talk about right now about SLA. This is V1. V1 is the Anycubic ABS-like V2 resin. This one, which is quite cool, by the way, really good. Using this 3D printer, which is very nice. Alcohol for cleaning my stuff. I'm talking about this stuff. Quite standard tools, and of course gloves. In here I made a hole in the wall outside of the house, and there is a cooler. Right now it's off, but when I need to just turn it off, close the door, so the odor and everything will just not going inside my room. Okay, so this is a ABS like. It's good, but it's not quite good for propellers. As you can see in here, I think it's on same thickness, almost the same form and design as the original one. This is the older transparent one. It's a Siraya Blue Tech, I guess. This one is quite expensive, 2 times more expensive. I think it's a gold standard right now for printing. It's like a hard stuff, and it definitely better than Anycubic ABS. Like, I mean, it better in a perspective, the strength.
So this is just a copy of this one, except I made a little hole here for I just wanted to avoid stuff like that. The problem that resin printer is not good at printing flat surfaces. You can just do this, but now you're gonna have these flat surfaces. So I designed that I don't really need this stuff, so this side, so I just sacrifice that side. Or you can just make this. Yeah. This is a V2, V3, V4, V5, auto support, manual support, V6, V7, which is also like, see, I was doing better and better every time. Okay. And I want to show you some results. How bad or how good those guys are. Okay. So this is the original one, original Propeller. This one. I was using this original Propeller in assembly. It was this Freewing EDF. It was original Freewing motor. And I was just measuring the static thrust in for some static, I forgot the current, like 200 watts or 150 watts. I wrote it somewhere, it just doesn't really matter right now. Okay, so always I was delivering the same amount of electrical power. And with the original one I was getting 535 grams of static thrust, original. Then I started to make all those propellers, and I started to measure value for each one. Oh, okay, see, 20 volts, 10.2 amps. Yeah, this is the power I was using. 20 volts, 10.2 amps. V1, V2, V3, V4, blah, 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 blah. So I got result 510 grams with V6. V6 is this one. Oh my god, so beautiful one. And yes, I tried to the maximum power. I tried to use it for the full 100 amps, 24 volts, 2.4 kilowatts. And I was getting almost the same amount of static thrust as this propeller, minus 5%, roughly. So, can you make a propeller by yourself? Yes. And actually it's very strong. Very strong. Not as strong as this one, but damn, it's very close. Also, I made V7, and yeah, V7 was 500 grams, and V7 was very strong as well. It's more thick in the base, in the root area. Interesting, why I wrote 510 grams? Oh yeah, it was 510 grams for V1. Actually, not too bad at all for this one too. But the problem is, remember I told you, it bends easily. The problem is when it spins at very high RPMs, the load is so high, the pressure is so high, so those props, they bend like this. And they lose thrust. So for low power, it's perfect. But if you want to get a lot of power, your propeller blades have to be very strong. They cannot bend, or if they bend, they must bend just a little. Yeah, so this is my result of testing. By the way, I also tried PLA, like that. Not exactly this one, but another one. I have many prints here. I just don't want to spend another hour trying to find which propeller I was using, but it was something like that. Not this one. It was 470. Okay, thank you for viewing my video. Bye.